1 point, if you like, that's in the shaded area, that should check in the original inequality. When you plug the x and y in, it must work. And then find at least 1 point that's not in the shaded region and plug it into the original inequality, and it should not work at all if it's not in the shaded region. Okay? If we've got that, then I think we can do that. But there are a couple of inequalities that pop up, especially later on when we'll be talking about systems of inequalities. That is, looking at more than one inequality at a time, where people sometimes have problems. So let's go ahead and take a look at those. Let's go to the board here. And what if I said to you, okay, graph this inequality. X is greater than 2. Well, how do you get that in mx plus b form? That's a question you might ask. Well, remember, everything we've done in terms of graphing the inequality began by graphing the equation. So perhaps this is a great time to go back and look at graphing x equals 2. Because we haven't discussed that in graphing equations. All right, let's talk about that momentarily. X equals, what does that mean? What does that mean? To me, that means that x is always 2. When y is 7, what's x? 2. When y is your social security number, what's x? 2. When y is big, x is 2. When y is small, x is 2. If y is blue, x is 2. Because x is 2. Well, one of the ways we have of graphing an equation is to plot points. Well, just pick a value of y, and x is 2. So if I go over here and I have something that looks like an axis, and let's say x is 0. Good. Y is 2. X is 3. Y is 2. How many points would you like? Another one? Sure. X is negative 4. Y is 2. Is that right? If you've been paying attention, you know this is wrong. But every once in a while, I like to do that just to see who's paying attention. Because if you're going out for cookies and coming back in and the tape is running, you're not following the instructions for the very first tape of do the work. We said that x was 2, not y was 2. So let's try that again. Only this time, no cookies, we pay attention. Give me a y value. Y is 0. When y is 0, x is 2. That's 2 comma 0. X comes first. 2, 0. Y is 4. X is 2. X is 2. Y is 4 is right up here. X is negative 2. X must be 2. Y can be negative 2, and that would be over here. I think you can see where this is leading to. When x is 2, all the points are 2 to the right of the y-axis. Let's draw in the y-axis a little better here. And therefore, we would connect these points. And there's my line, x equals 2. All right? But we don't want x equals 2. We want x greater than 2. And why am I turning the page? Because I want to draw it in lightly. So let's start again with x is greater than 2. And we draw our axes. And I'm going to try to lightly draw in x equals 2. Probably so light you can't see it, but you know it's out there. You see my hand moving. Now, is it solid or is it dashed? Because we have the line. We kind of skipped the first step because we can't get x is greater than 2 in mx plus b form. We did graph the equation, x equals 2, lightly. Next step is it solid or is it dashed? Well, there's no equals here, so it must be dashed. And there is the dashed line for x equals 2. What's the next step? The next step is shading. But wait a second, we said shading above or below. How can you shade above or below a vertical line? You say, well, if you're a wise guy, you'd say, well, shading up here. I'm the wise guy. You can't be the wise guy. You got to pass the class. So that's silly. Well, we got to go back to our meaning. What is the meaning of x is greater than 2? X is a number that's greater than 2. Y could be any number. So, for example, an ordered pair that would work might be 3, 1. Right? X is 3. 3 is greater than 2. Y could be any number. Y is 1. Let's plot the point 3, 1 and see where it is. X is 3. Y is 1. There's a point that should be in the shaded region. That should give you a hint as to where the shaded region is. If it doesn't, let's find another point. X is greater than 2. X is 5. Y is negative 3. All right, let's extend the x-axis here so we can find 5. 1, 2, 3, 4. X is 5. Y is negative 3. Does that give you any hint as to where the shading goes? Well, you should see that for x to be greater than 2, x has to be further away from the y-axis than this dashed line. And therefore, we shade to the right. Because in terms of x, on the x-axis, the greater than is to the right, less than is to the left. What if this had been x is less than 2? Same line, same dash, only the shading would be to the left. X is less than 2. So that's one special case. Remembering that x equals is a vertical line, but if you don't remember that, just plot points, as I did. Draw the line lightly and shading correctly. You could probably guess what the other special situation is. How about y is less than or equal to negative 1? Now, we'll look at this two ways. Because this we can get in mx plus b form. We'll look at it that way. We'll also, more importantly, look at what it means. What does y is less than or equal to negative 1 means? It means that x could be anything you want. Any number you'd like. But y must be less than or equal to negative 1. Y could be negative 1, of course. Or negative 1 equals negative 1. Y could be negative 1.5 or negative 2, negative 7, negative 10 million. As long as it's less than negative 1. Now, let's go back to my promise to show you how we can write this in y equals, or y is less than or equal to mx plus b form. You say there's no x. You're right. We got to put something in front of the x that's a slope, and it's got to make the x go away. What number do you know if I multiply it by x, x could be any number, when I multiply it by x, it goes away. The only number I know is 0, because 0 times x is 0. Even if x is the national debt, which is a bigger number that I can pronounce, what happens? 0 times the national debt is 0. Now, these two are exactly the same. They both represent the inequality y is less than negative 1. The question is, what does a 0 slope mean? The definition of slope was that it's the change in y when x increases by 1. If the slope is 0, that simply means, hey, if x increases by 1, y doesn't change. X increases by 17, y doesn't change. That should hopefully give us a hint when we graph the line for y equals negative 1 that it's correct. Okay, let's go ahead and graph that line. Y equals negative 1. Okay. Let's do the same thing you did before. What did we do before? We said, okay, hey, let y be negative 1 and pick any x you want. Before we had x was 2, we picked any y we wanted. Let's be careful to make sure we're picking the right letters, right numbers for the right letters. What should x be? Let's x be 3. If x is 3, y is negative 1. X is 3, y is negative 1. By the way, if you want to use the mx plus b form, x is 3, 0 times 3 is 0, minus 1 is negative 1. Let's pick another x. X is negative 2. Y is negative 1. X is negative 2. Y is negative 1. By the way, you say, wait a second. If this is mx plus b form, that's the y-intercept. Hey, the y-intercept is when x is 0, y is negative 1. I think we can figure out what this looks like now. Let's draw lightly. That's not too light, but that's okay. Our line. It's a horizontal line that's 1 below the x-axis, always, because y is -1. It really doesn't make a difference that I couldn't draw it in too lightly. This pen was very excited because it contains equal. Less than or equal to means I darken in the line. So let's make a good job darkening the line so everybody can see that it includes equal. And now it's less than or equal to. Well, now we can deal with above and below. And obviously a y less than -1 is all the y values below -1. So we shade in the area below the line. And there is our graph of y is less than or equal to -1. Can we check this? Of course. We can pick points. For example, here's a point. Let's see, x is 1, 2, 3. Y is -3. Plug in 3, -3 here, and we'll find out that -3 is less than -1. It checks. Pick a point up here. How about a point right here? This point is 1, 0. When x, it doesn't make a difference what x is, but when we go over here, is 0 less than or equal to -1? No, it's not. This point is not in the shaded region. It doesn't work, and we've checked, and this is the correct graph. So, what we've seen in this lesson is how to graph linear inequalities in two variables. We will need this later on when we talk about systems of linear inequalities. And those of you who are planning to go into business and major in a business field in college, you will eventually get involved in college mathematics in something called linear programming. And linear programming is based around the use of systems of linear inequalities. So there's real usage here. Now, before we can get involved in systems of inequalities, we first have to learn about systems of equations. And in case you haven't guessed it, systems of equations is our next lesson, which will be lesson 10.